And our next speaker is Dr. Marcelllo Melini from the University of Minnesota. Marcelllo is a veterinarian who graduated with his DVM from Guatemala and completed his master's degree also there in applied statistics. He has worked in the swine industry in Guatemala for about 10 years, and he's now a second-year PhD student working with Dr. Cesar Corzo.
Check. Well, thank you for the introduction. I'm going to present the results from a study to answer if some PRRS virus variants have the same level of infectivity. So to start off, some key concepts of epidemiology just to keep in mind. First of all, what is infectiousness? There are very different definitions. The most common one is the relative amount of an infectious agent that an animal can transmit. So this is at the host level. If we go to the pathogen level, we have infectivity, which is the amount of an organism that is required to initiate the infection. Again, another key concept towards the pathogen is virulence, which is the severity or intensity of the disease, and also pathogenicity, which is the ability to cause disease. So keep those 4 key concepts in mind. And again, I think most of us know more about PRRS from what I'm presenting, but a reminder, it's an RNA virus belonging to Arterividae family. It's non-zoonotic, pig-specific, and also endemic in the United States and other countries around the world. Again, for several years, it has been described as costly, between $6 to $15 per pig, and more than $500 million a year in the United States alone. So where does these losses come from? Well, increased mortality. We have decreased growth performance in growing herds, reproductive failure, and also, again, medications that come from associations with other pathogens, and also the control of these other pathogens. So how does this virus transmit between pigs and farms? The direct route, of course, nose-to-nose contact between an infected animal and a naive animal, orally through semen, transplacental, also feces. So these are some examples of the direct transmission. Indirectly has been described also through fomites, different kind of fomites, airborne, and also through needles. Some quick history about some viruses across the United States or the world. The isolation of the Lelystad virus in the Netherlands, 1991. 1 year later, the VR2332 isolated in the United States. After that, 9 years passed. The appearance of the Minnesota 184 isolates. We go then to 2014. We have the 174 virus. Or more recently, we know the variant of the L1C144. So again, what about this kind of new virus? It has been around or talked about for the last 3 years or more. Let's talk about the emergence of this one. So in 2020, in southern Minnesota, veterinarians and producers began to notice simultaneous PRRS events. Again, simultaneous PRRS events is not uncommon, we hear it a lot, but something was different about these events. Finishing farms in the same region were breaking with PRRS. These producers and veterinarians were describing it as more severe, more aggressive. They were seeing an increase in mortality or signs. And they were saying, okay, what I've been talking to my neighbor is very, very similar. So through the Morrison Swine Health Monitoring Project, a case control study began. And through this study, it was determined that the cause of this event was this variant of the L1C144. Another study conducted said with this specific virus said that also suggests that it came from a recombination, as we saw from the last speaker, from an lineage 1 sublineage C in the R5 sequence. So from this event, we have many answers, but with answers, we at the same time have more questions. What makes this virus so different? Why does people say it behaves more aggressive? So from this, we designed a study in which we are addressing three main questions. First of all, is to compare the infectivity of PRRS viruses. Second, to characterize the viral sharing patterns of these viruses, and to describe the severity of histological lesions generated by these three different PRRS viruses. So to start off, some materials and methods. Start with the virus. So we gathered three different viruses from the UMN Veterinary Diagnostics Lab. The first one, of course, the L1C144 variant, which is the virus of latest concern to the US swine industry, followed by L1174, which is the previous concern to the swine industry between 2014 and 2015. And we needed one more, which was a lineage 9142, just as a reference virus. So each one of these was propagated in Mark 145 cells until a desired titer approximate of 10 to the 5 TCID50 per ml was reached. So from this, once we gathered this, we said we need more dilutions or doses to test. So from this first inoculum, we did 5 tenfold dilutions. So we have 7 doses from 10 to the 4, 10 to the 3, 2, 1, and 0. 7 doses because 6 were destined for pigs, 1 for titration. In the sense, these dilutions were made on the same day as the challenge day. These went to the facility where the pigs were located, and randomly one of these doses went back to the lab for titration. What were the results of this titration of each dilution group? Well, in the right column is the expected titer that we wanted from the dilutions. Again, it's PRRS, TCID50 is not perfect. The Carver method is not perfect, so we have these approximate doses for each one of the groups that are represented here. So now we have the virus. We know what we're working with. Let's check the pigs. Okay. So we purchased 4 week-old barrows that were ELISA and PCR negative to PRRS coming from the farm. So we, from this, we checked, or we bought 30 pigs. So we have 5 groups, then 6 pigs per each one of these subgroups, and also additionally 6 more pigs just as controls. Each one of the pigs was randomly allocated in each subgroup, and each subgroup was randomly allocated to a room. Each one of the pigs of the challenge subgroups were inoculated intranasally with 2 mLs, 1 ml per nostril, and the control animals were sham inoculated with MEM. Now let's check the facility. It's at the University of Minnesota, the veterinary isolation facility. As I mentioned, the pigs were housed individually. In order to gain access to the facility, we have to shower in, and to move between rooms, we have to shower in between rooms as well. Each room had an anteroom, or has an anteroom, that is dedicated just to boots, coveralls, and specific material to the group. No boots or coveralls or material was exchanged between these rooms or subgroups. And again, when previous to enter the main room with the pigs, we and the people helping wore clean gloves, face mask, a bonnet, and also a plastic gown that was changed in between every animal. All of these materials were changed between animals to avoid cross-contamination when handling both the sampler and the holder of the pigs. And I want to, if you can check these 2 pictures, this is where the animals were kept. They're individually placed. For each one in the room, a solid divider was placed, so the pigs didn't have a direct contact, no nose-to-nose contact, feces contact, urine. Each one of them had their own feeder, their own water supply, so we try to avoid every contact to avoid again, cross-contamination and keep biosecurity at the highest possible. So to make you understand a little more about the BIF, which is the veterinary isolation facility. So we had the control group, 10 to 0, 1, 2, 3, and 4. When we went inside the facility, shower in, go to a control room, again shower, go to a 10 to 0, shower, and so until 10 to 4 was the last room. So what about the distribution of the pigs inside the room? Checking this is the clean corridor, dirty corridor. So we entered through here to the anteroom, place coveralls, boots, gather the material, and then we sample each pig from the far end of the room going up until the front of the room. So again, every room was sampled the same way, the same sequential way, to avoid any type of unwanted movement and just to maintain order, again, for the lab. Keeping up samples that we collected. So 3 days prior to the challenge, serum was taken to assess if they were ELISA and PCR negative. Once we make sure of that, day 0, date of the challenge, previous to challenge, we collected rectal and nasal swabs, and then the same procedure at day 1, 4, 7, 11, 16, 21, 26, and 30. Day 4, serum samples were also collected, and at day 11, 2 pigs were selected from each subgroup for euthanasia and histopathology sampling. And the rest of the samples were submitted to the BDL of the University of Minnesota for PCR. So how did the analysis? Again, titration was done through the Carver method. We chose the post-challenge as the comparison to assess infection. We consider pigs if they were with a CT value below 40, according to recommendations from the BDL, and to assess the odds of the pigs being positive at day 4 post-challenge with a logistic regression model, and also to assess the median infectious dose. We did a probit model with its 95% confidence interval. So let's check some of these results from the first objective, infectivity. So we see the far left y-axis is the number of pigs per subgroup until 6. This y-axis on the right side, each subgroup 10 to 0, 1, 2, 3, and 4. Each column represents the virus I just described in here by RFLP, not by lineage. And the yellow means positive and green is negative. So if we can see, yes, the 10 to the 4th, of course, the highest, all of them are going to be positive. But if we keep going down, in this case up, but in the dilution going down, we can see that the reference 142, 10 to 0 didn't have anything, 10 to 1, just 1 pig, then over 50% were positive. 174, yeah, most of these were positive in the highest dilutions, or all of them, and less than 50% in this were positive at day 4. Now let's check the variant 144. You can see that even the lowest dilutions groups, subgroups, have over 50% of the pigs as positive at day 4. So keeping this in mind, we have the logistic regression adjusting for the TCID50. We have that having the lineage 9, 142 as the reference. The 174 is those pigs challenged with this variant are 2 times more likely to be PCR positive at day 4 post-challenge, but this is not statistically significant because of the confidence interval. Meanwhile, let's check the 144. Those animals challenged with this variant were 13 times more likely to be positive at day 4 post-challenge. Let's check now the probit model. So for the ID50 and the minimum infectious dose, we can see again that the 142 and 174 here on top, the ID50 is pretty similar, 10 to the 2.6, 10 to 2.3. Again, expected. This has been described by other researchers. And let's check the 144. It has TCID50 between 10 to the 1.3, while the confidence interval can go for 0.4 and 2.2. But the minimum infectious dose is pretty similar. This is at least one pig was infected with this one. But this is what is required to infect at least 50% of the exposed animals. Results from the second objective. So we can see in the left y-axis is the range of CT values. Again, it only ranges between 20 to 40, that is above this negative. The right y-axis is the dilution groups. Again, 0, 1, 2, 3, and 4. The green one is 142, red one 144, and blue 174. So for the rectal swabs, you can see fecal shedding. Day 1, there is no presence by PCR. But at day 4, all of the viremic pigs were shedding. There's not a specific trend. We can see that in some cases, some pigs, the shedding was continuous, other was in an intermittent way. Also, as a reminder, a couple of slides before I described that at day 11, 2 pigs for each subgroup were chosen for euthanasia. That's why some of these pigs don't continue until day 30 with the shedding, is because they were euthanized. But the ones that continue, again, some of them were able to shed until day 30 post-challenge. Now let's check the nasal swabs. The trend is pretty similar, more consistent in some way. If we can see the 10 to the 3s and 10 to the 4s, more pigs shed until day 30. But in the highest dilution groups, there's one of the 174 at day 1, and at least one pig from each subgroup at day 1 for nasal shedding. So this is through, again, PCR. Let's check some histology results. Here in the first column, we have the dilution group, and also first the control groups, second the virus, and then the tissues or the lungs, the organs that were collected. So first of all, we had the 142. Yeah, some pigs presented lung lesions, not all of them. One presented brain lesion, no heart lesions. Some in the high dilution groups, the bronchial lymph node was affected. If we move to the 174, again, some lungs are affected. Not that many, just one in the highest group has brain and heart. Not that many lymph nodes affected, one here, another one here. But if we go to the 144, again, all of the challenge animals had lesions in the lung. Most of them either had brain and in the heart, or both at the same time, so this is a significant find. Also more findings in the lymph nodes, so also that's to take into consideration. With this, I'm not a trained pathologist, I apologize, but we all have seen slides of healthy lungs. We can see that this for sure is not a healthy lung. This is courtesy of Dr. Stephanie Rosso. And what the main finding in the lung was interstitial pneumonia. Every finding was like this. We can see that it's very severe. It's supposed to be more like these areas, but it's just with macrophage cell debris. And if we go to the heart, the main finding was myocarditis and endocarditis. Again, every study has limitations, sample size groups, just 6. Again, experimental conditions are not the same as farm conditions. Again, farms have more contact between pigs or other pathogens present circulating. And also the experiments or the groups were not conducted at the same time. They were one after each other. And some conclusions. Well, for the first objective, yes, compared to the 142 and the 174, the variant L1C144, because fewer viral particles to successfully infect half of the pigs at day 4 post-challenge. And shedding can be either infrequent, intermittent, or it can last until day 30. That was the last sampling day. And also this variant has more frequent and more severe tissue lesions in the lung, heart, and brain compared to other PRRS virus that we assessed. And with that, I would like to thank all the people that helped me in the study, either design or collect samples, the MGM team, the Swine group of the the VDL, my thesis committee, and of course, the and Rapid Agricultural Response Fund. So with that, thank you.
Questions for Dr. Melini?
All right, Marcellо, thank you for that presentation. My question is, how do you expect these results to translate to the field? And specifically, do you think that the, I guess, heightened infectivity of this strain is important from like the within herd dynamics, or is it really about the ability of the strain to maybe leak through biosecurity?
Thank you. I think it's more through biosecurity in the sense that we have many barriers that keep in check the virus, but as we are seeing that high doses reinfect pigs and low doses other viruses just don't go through, maybe this process of this specific variant at each step inside the barn, let's say the bench, the shower, just helps dilute. At some point that go, let's say the 174, 10 to the 0, 10 to the 1, it's like, okay, no pig's gonna get infected. But if the virus manage, even with those dilutions inside each one of the process steps of biosecurity, manages this 1.3, 2.5 TCID50 goes to one pig, the virus is just expecting an opportunity. So I think it's mostly through biosecurity.
Another
I have
question.
a question here, Andre. So yeah, thanks for that. I don't doubt the results because they agree with my preconceived notion, but when you do these types of studies, you did an intranasal challenge, right?
Yes.
And so especially in this case where you did them at different times, what did you do to sort of minimize the opportunity to get for variation, right? With intranasal, notoriously it's hard to get the same volume to the same location every time.
Yes.
And did you have the same person administering it each virus, and then were they blinded to what virus they were administering?
Thank you. Answering the second question, no, this person was not blinded because answering the first question, that person was me. So I did all the inoculations. So I tried to make sure the project was on the line with my hands. So I say I have to get these pigs inoculated. So I make sure that each dose in each nostril went in, and try to minimize this sneezing or any type of return of the dose. Sorry?
You knew the groups. You weren't blinded. You knew which virus you were
Yes.
using?
In looking at your data, it appears that as the concentration went up, the shedding went up, and that may be a function of the time frame that you looked at, but do you think that is a dose related?
I think it can be dose related. Yeah, we saw this pattern, but it changes when we see it from an individual level. Just as a group, it has the same trend.
Yeah, that's always been the debate is when you look at it over time, will you get the same concentration because more animals will become infected?
Mm-hmm.
Do you have any comments on the onset or duration of clinical signs based on the virus or the level that was administered?
We didn't exactly assess the signs, for example. And these behave differently because they were kept separately. So there's not this constant infection. So they didn't develop any notorious signs. Of course, they were lethargic for 7 days. They didn't go exactly off feed, but were eating less, some anorexic, feverish. But it was, if they were positive, they were showing similar signs.
Great. I have one quick question for you before you leave, Marcellо. You showed us the graphic with the odds ratios there was a numerical difference between the 174 and 144 compared to the reference, which was 142.
Yep.
Did you check to see whether the 174 and 144 were different between each other?
Yes, I checked the 144 as reference as well, and yes, there's a significant difference. Thank you.
Thank you very much. Please join me in welcoming him to the presentation.